unless I'm going to be embarrassed. Clear!
It won't start. The mixture's back.
David, good to see you once again. Thank you so much for giving us a hand. I want to ask you, why do you go through the trouble of putting floats on your plane? Why do you float fly?
Well, first, thanks for inviting me, Don. This is always a lot of fun. Why to float fly? Well, there's two probably really good reasons. The practical answer is that it opens up a lot of flying sites to the modeler. You can now take your land plane and fly off a river, a lake, whatever.
Yeah, clubs are losing fields all the time, it seems. Gives you another place to fly from.
It's becoming a real problem.
Yeah.
But to me, the most important reason, it's a heck of a lot of fun.
Yeah, yeah, gorgeous scenery too. Right. Well, Dave, can you give us some tips on selecting floats and getting started?
Sure can. Before we go into that, let's look at what we're going to fly today, and then we'll go into the details of selecting your float.
Great, let's go.
This is the Goldberg Cub on Goldberg Super Floats. These floats were designed specifically for this airplane. We went through quite a design process, did a lot of research, and a lot of different models before we ended up with this particular float for the Cub. It's an excellent combination and flies very, very well. As we'll see later on, you can use these floats on other aircraft quite well. A couple of interesting points. We use two rudders in the back. This helps for steering at low speeds. And if you notice in the back here, we've added what we call a lower ventral fin. And most models, you probably want to add this, because when you add floats, you lose a little bit of yaw stability, and this improves that directional control quite a bit. Here we have probably the most popular 40 size sport trainer around, the Goldberg Eagle 2. This is a 40 size airplane, and we have the 60 size Goldberg Super Float. It really works very, very well. You'll note here, again, we're using the lower ventral fin, which comes with the kit, to help with the yaw stability. I've flown this both ways, with and without the fin. Works pretty good, but again, we would recommend that you use it. Good combination, great way to start in float flying. Here we have a little bit of an experiment. The people at Gulfstream took a Ace 120 size float and attached it to a Goldberg Tiger 2. And the tip floats are from Lanier, which can be purchased separately. Interesting experiment. We weren't really too sure how it would work out, and it worked out beautifully, as you'll see later on. Probably the point here is don't be afraid to experiment. And when it's as successful as this was, it's a heck of a lot of fun.
David, these are the water rotors we're using on this project.
Yeah, these are the Ernst water rudders. It's a very nice upgrade. It features a kick-up rudder, retractable if you like, and they come in two sizes. Most importantly, they work very nicely.
These tip floats come to us by way of the folks at Lanier RC. They're to their plane called a Seabird.
Yeah, this is what was used on the Tiger 2, as you say, as a tip float. It's really a simple modification. It comes in two halves with a plywood insert, epoxied together, and then they use a nose gear bearing mounted in the wing to attach it. It also makes it adjustable and easy to remove and reinstall.
Here we have the Ace Seamaster 120. This is a little bit different than what we showed before. We had an airplane we added floats to. Here, the airplane's fuselage is the boat itself. A little bit better compromise. It's a better boat and a better airplane this way. Things are a little different when you have this configuration. One, you have the engine on a pod to keep it away from the water spray. And we do the same with the tail, make a T-tail configuration to keep it out of the water spray. All in all, this is a really good example of a flying boat, and it flies very, very well. Here we have the classic of all classics. This is a third scale Balsa USA aircraft built by the people at Gulfstream. This is a really beautiful example of what can be done. Full detailed Edo floats. This is a very scale airplane in many ways, and it flies very much like the real one. We're running on an Infinity 4.4 cubic inch on gas, and it's almost too much power. Again, an excellent flying airplane that flies just like the real aircraft.
This Supermarine S4 was built by Steve Lingle and Dave Vernoy in Anchorage, Alaska, for us, specifically for this project.
Mm-hmm. It is a beautiful model, as you can well see. Has a very classic lines. In fact, it held the world speed record for propeller aircraft in 1925. The original prototype, the full-size aircraft, in fact broke in two in the Chesapeake Bay, I believe in 1925. This model here has a Pegasus 4-cylinder engine and weighs about 32 pounds. Truly a beautiful aircraft.
Yeah, it's from RC City. I think it's a short kit.
Yes, with a fiberglass fuse, foam cores, and plans. A lot of work, but well worth it.
David, are there any special considerations in the conversion process between a land plane and a seaplane?
Yeah, there are a couple. When you are choosing your engine, always choose the bigger of the range that's recommended for that airplane. Mm-hmm. Because of the added drag and the weight of the floats, the bigger engine will come in handy. Okay. When it comes to choosing a propeller, again, choose the larger diameter, lesser pitch recommended for that engine, again, to overcome the added weight and drag of the floats. Uh-huh. When it comes to choosing the floats themselves, I always like to recommend the larger range for the airplane. What I mean by that is that, let's say you have an airplane that weighs 8 pounds, and you have a choice between a float that's designed for 8 to 10 pound aircraft or a float that's designed for 6 to 8 pound airplane. Choose the bigger float.
Mm-hmm. What would be an example of how a plane would react with floats that were in fact too small?
Well, having made that mistake, I can tell you firsthand, the airplane would still float in the water quite well. That wasn't the problem. Uh-huh. But when you turn downwind, for example, the downwind float would want to be submerged. Mm-hmm. Also, getting onto the step, getting ready to take off, the transition was difficult. I did fly the airplane with a smaller float, and it flew quite well. When I went to a bigger float, I couldn't tell the difference between the weight and the drag. It was very tiny, yet the weight handled on the water was so much better. It was definitely worthwhile going to the bigger float.
Dave, let me ask you several questions. What's the deal with cross bracing? Is that necessary?
Necessary? Well, most of the situations I've seen and used myself, I would say yes. The whole idea of the cross bracing is to stiffen up the landing gear. If you were to have a hard landing, for example, the tendency would be for the floats to come apart, and it gives it some stability this way. Is it necessary in every case? Probably not, if you had a strong enough landing gear and rear mount. But in most instances, yes.
Okay. What about water rudders? Are those necessary?
I would say yes, again. We're going to fly a model you'll see later on that doesn't have any, and it's very difficult to taxi. Some aircraft have only one, full-size and models, and they get by fairly well. When you have two water rudders. That really seems to help a lot, especially when you're taxiing slow and there's a little bit of a wind going on. So I would recommend 2 water rudders if you can afford it.
Okay. What about spray dams, Dave?
Okay, the idea of these, that's to prevent the wake from being sucked up into the propeller. In our models here, we don't really seem to have a problem, but sometimes there is a problem where if this is the inside of the float, there's a bit of a wake that's generated, and the propeller vacuum sucks it up, and the water gets into the propeller, and it's very, very hard on propellers. So that's a good way of preventing that. And if you can, you should always use a plastic prop, nylon prop on the smaller engines.
Let's take a look at the setup, specifically the angle of the floats and the placement of the step. On a wing that has a flat bottom airfoil, like a trainer, the bottom of the wing should be parallel to the top of the float. On a symmetrical wing, like this Cap 232 shown, start with the wing at 2 degrees positive. In other words, the floats will droop down slightly. The step should be at or slightly ahead of the CG. You may want to move the CG slightly ahead for the first flights. This is a generic setup that should work on just about any float plane.
David, I know it's important that you keep water out of your equipment when you're float flying. Can you tell me what kind of steps you take to ensure that?
Sure, Don. It's not that difficult. A few common sense things will go a long way to protect your equipment. You probably want to wrap your receiver up in a balloon or a baggie and seal it shut, just in case an accident may happen. Sealing the wing area, the wing saddle, with silicone is another really good idea, good practice. If you're using a rod-type push rod or a nye rod, some Vaseline where the push rod comes out helps prevent water backwashing in. You don't want to mount your switch on the outside. Water plays real havoc on switches. You want to mount that on the inside and use a wire, such as a Dubro mount or something like that, to turn it on and off. If you think there might be any chance of water leaking in somewhere on the airplane, a little bit of tape can go a long way to prevent that. And go fly it. Try a flight, take it apart, and look to see if any water has come in, and seek it out and find out where it came out, where the water came in. And go enjoy the flying. At the end of the day, it's probably a real good idea to take the wing off and make sure that all the humidity can get out of the airplane.
Our good friend Paul Martin told us about this wonderful product.
Yeah, this was a really great discovery. Applied before you fly, it protects your plugs, electronics, etc. The Corrosion X is available at marine stores, and a similar product available at hobby shops is called Aeroplate from Aerotrend. Here we are showing a new offering from Model Magic, BJ Floats. What makes these a very interesting choice is that they're made from a foam that's pre-shaped. They can't fill with water and sink. Believe me, this alone is a great feature. They come in 6 sizes with clear instructions that can help you easily transform almost any model to float flying. Ask for BJ Floats at your favorite dealer or call Gulfstream Direct at 1-800-531-1784.
David, I know we're getting ready to go fly. What kind of things are you going to show us?
Well, we're going to go over a few things that are special to a float plane. Different types of taxiing. Idle taxi, plow taxi, step taxi. A little different than what you would do on a land airplane. An interesting thing about the plow taxi, that's like the middle speed of the taxiing range. As you go faster and faster, the nose will pick up. It'll get pretty steep, and that's at the stage we call plow taxiing. And that's important to know, because what happens is the center of buoyancy moves back. And this reduces the tendency of the airplane to weather vane, which makes it easier to turn. So if you have problems turning, if you go to a plow taxi condition, that makes it a little easier for you. Also, it's used in rough water as well to cut through the waves. From there we go to step taxiing, step turns. We're going to go into takeoff and landings, rough water takeoff and landings, and some side slipping. And If the engine should fail, we're going to show you how to retrieve your airplane out in the water.
Great. I can't wait.
Well, let's go do it.
Let's do it. Dave, here we're showing a number of retrieval techniques for planes that are dead in the water. We have a RC boat here pulling a length of line and a tennis ball to retrieve a plane, and we show Buck picking up a plane with waders and show a small John boat. The point being that if you're going to go fly, you need to have some plan for retrieving a plane.
Absolutely. It's probably a really good time to point out that you should have a very reliable engine. If you're taxiing out in the middle of the lake and the engine quits, that's a pretty bad time. It always helps if you fly upwind as well, so the airplane will drift back towards you, not away from you. But I agree, you really need to have some form of recovering your airplane before you even start to fly.
David, it seems like neither of us had the heart to talk over the wonderful sound of that engine.
I love that radial sound. What we're showing here is idle taxi. That's usually used in confined areas like this. The engine here is at idle, and you're moving at a pretty good clip. If you're on land, of course, let's say on a grass runway, you wouldn't be moving at all. Water rudders are really important at idle taxi. Twin rudders are very helpful if you have them on your plane. If you have no rudder, especially in a wind, it can be very difficult to taxi, especially at idle taxi. Full-size pilots like to use idle taxi because the nose stays level and it's much easier to see. And something you should know about idle taxi, especially if the water's a little rough, there's a higher risk of getting water spray into the propeller, which can damage the prop. So keep that in mind during a rough water idle taxi. As you increase power from idle, the airplane will accelerate and the nose will pick up and enter a plow taxi position. This moves the center of buoyancy back, which helps in steering and keeps the spray out of the propeller. Now, as you add even more power and release the up elevator, the airplane will level out and skim on top, such as this. This is useful for getting around more rapidly. You can also, while you're in a step taxi mode, turn the airplane. Your main steering is done by the air rudder. I think a good point to make here is the fact that you should always have the ailerons turned into the wind to help prevent flipping over. This is really useful if you're flying out of a small area. You start off downwind and do your step turn, finishing into the wind.
David, are there any differences between taking off on water and taking off on land?
Not really, Don. It's very similar. Just apply the power, keep it straight with the rudder, and try not to jerk it off the water. Try to be smooth. You may have noticed when the full-size Beaver took off that he lifted one float off before the other. He did that on purpose. With a model airplane, we have so much power we can just unstick quite easily. But on a full-size aircraft, without that luxury, the floats tend to stick to the water, especially on calm water. So what they do is they break one float free, then the other. This makes it quite a bit easier to take off. Certain conditions, a full-size airplane, especially if it's calm, can't get off the water at all, and they have to make their own waves. But really, on a model, there's very little difference between taking off land and water. Just do it smoothly.
David, I know that full-scale pilots set up a rate of descent when landing their planes and are actually surprised when their pontoons hit the water.
Yes, Don, that's 100% correct. But when we're flying an RC plane from the ground, we have a totally different perspective. We can actually judge the distance between the floats and the water on landing much easier. The only difference between landing a float plane and a land plane is that I think it's best if you come in with a little extra speed, so when you rotate, the rear of the float does not strike the water first. And when you're able, always try to land into the wind.
Dave, I think side slips are really cool, and I've tried to do these. I would really like to learn, but when I put in rudder, it seems that the plane wants to roll with me.
Yeah, they will, especially a high-wing airplane such as this. What's happening to you is that when you apply, for example, in this landing, we're using right rudder. Well, the airplane's going to want to roll right quite a bit as well. Also note that when you spin an airplane, you apply rudder.
Mm-hmm.
So when we're approaching to a side slip, of course, we're getting ready to land. That means you're slow, and applying rudder means you can spin.
Right.
The key is the first thing you do is get the nose down, get
Mm-hmm.
the speed up. Then watch, we'll get the nose down, apply the rudder, and opposite aileron there to straighten it out. But you got to keep the speed up.
Mm-hmm.
The hardest part is the transition, is getting out. Slowly out with the rudder,
Right.
and then you fix with elevator and aileron. It's not an easy maneuver. It takes a lot of practice.
Mm-hmm. Neat. David, what's the difference between the takeoff we've just shown and this rough water takeoff?
There's a big difference. In calm conditions, we try to take off smoothly and gently. When we have rough water such as this, we want to get out off the water as quickly as possible to save the propeller airframe. So what we do is we quickly apply power with full up elevator. But as soon as it breaks water, we want to release the elevator and continue a gentle climb out, like that snap roll there.
Yeah, or these.
Like the rough water takeoff, we want to get it over as quickly as possible. So in this case, we do want to do a full stall landing into the wind, into the waves, such as this.
These geese here on the Chesapeake Bay have made a rough water takeoff. Beautiful shot, Ken.
This is really interesting. This prop is after only 4 flights. In spite of us being as careful as possible, this shows what water can do to a propeller. We're having some difficulty maneuvering the model of the Supermarine. Like the full-size, we don't have any water rudders, which makes it very difficult to steer, especially if there's any breeze at all. As you can see, it keeps on weather vaning into the wind. We had some other handling problems due to the fact that the landing gear was very close together and the aircraft was very tall. In fact, the full-size aircraft was towed out to the middle of the lake, started up, pointed into the wind, released, flown, and when they landed it, again it was retrieved by a boat, so it never really had a taxi. Once in the air, of course, this airplane flies great.
Probably 50% of this tape was filmed in Alaska, which is the center of the seaplane universe. It seems Lake Hood and Anchorage is the largest and busiest seaplane base in the world, with some 800 takeoff and landings a day being representative. So with that kind of seaplane presence, it's not surprising that modelers in Alaska embrace this form of flying. We were honored to have the owners and their planes allow us use for this video. Clearly time, effort, pride, and commitment are the common qualities these planes present. This Edo, whose maiden flight you are watching now, was built by Ray Agan. From Ed Westbrook plans, it weighs 10 pounds and has a Super Tiger 90.
I'd like to say that this airplane for a test flight flew just beautifully. A real testament to the workmanship and design, being a scratch-built airplane.
Bob Stevens built this Proctor parasol. It's powered by a Sato twin. It's a 12-year-old airplane. Bob scratch-built those floats, Dave.
Again, this airplane, I'm familiar with the Antic series, etc., etc. I've never seen a parasol before. It was a real delight to fly. It's very reminiscent of the 1920 or so.
Mm-hmm.
Again, a very easy airplane to fly, very light. With a four-stroke, it really makes it look like you're flying a berry low or something of that nature.
Right. It's beautiful.
I was also surprised, and I looked at the floats. They look awfully small, but being such a light airplane, they were very adequate and worked very well.
Right.
This goes to show a good airplane can make you look good.
It's beautiful. Really nice. This de Havilland Beaver is another Ray Agan plane. It's from a Unionville kit. Ray put flaps on it, retractable water rudders, nav lights. He scratch-built the floats. It took 5 to 6 months for him to build it, and it was a featured airplane in Model Airplane News.
I sure am a lucky guy. I get to fly all these really cool airplanes. At the expense of sound like a broken record, this airplane flew flawlessly. It's very easy to fly, easy to take off and land. Very realistic.
It's a beautiful airplane.
I guess this is what they do in those long Alaskan winters.
I wish you'd do one for me. That is beautiful. David, the level of detail on this plane is really remarkable. I was talking to Ray, and he told me that he took a picture of this plane and took it to Ketchum Air Service, whom this plane was patterned after, and took it to the owner, and the owner looked at the picture and said, where was this taken? Ray told him the lake, and the owner got upset that the plane should not have been at that lake. It had no business being at that lake, and he was really getting upset. So the quality and the detail was enough that the owner of Ketchum Air Service mistook this model for one of his own. This Telemaster is Dave Domus's. It was built from a Hobby Lobby kit. Dave boasts 30-minute flights at half throttle and an unbelievable dead stick flight time of 19 minutes. He said he had to climb up till the plane was almost a speck, but he milked 19 minutes out of it.
One of the reasons why we did this videotape is to really show another really interesting aspect of model aviation and show how much fun you can have. And I hope this brings more modelers into trying something new and different.
Once again, these guys allowed us the use of their planes, the use of the facilities, both here and in Maryland. The success of this video project was to a very large extent due to their help. Thank you guys, you were great.
And I'd like to thank them too.
David, that was wonderful. We had a great time. Impressed by a lot of things. The Balsa USA Cub flew very majestic-like, it flew like a real plane. We were all pleasantly surprised by our little experiment, the Tiger II on its center pontoon float. All in all, it was wonderful. Thank you so much.
Well, thank you, Don. I had a great time too. I learned a lot, and I really look forward to doing this again.
Great. Let's go fly some more.
You bet.
Okay.